Good morning, guys. So today we're going to look at some of the homework you did last night, which is sorry, I don't know why I can't get rid of that stuff there. Okay, anyway, there it is there. Okay, so we're going to take a look at question 4. Sorry, we're going to take a look at question 3, and then I'm going to move on to question 7 myself, and that means you should be able to do question 5 and 6 today yourselves. Okay, so that's the plan. Yeah. Okay. Right. So let's take a look at question 3 first of all, and let's do maybe the third part. So question 3, part 3 coming up. And I'll just get my tablet flat so I can write on it. Okay. So what are we doing here? So we have this shape, looks a bit like a Pac-Man, and we're told that that's an exactly a right angle there because it's this zone in here. I should have colored that in yellow. That zone is 3/4 of a circle. Okay, so we're asked to find the area, right? Calculate the area. Yeah, so we're asked to find the area. So we're told that that distance as well is 4 centimeters. So we're told the radius is 4 centimeters. So let's work out the area of the full circle. So area is equal to pi by 4 squared. So pi r squared, which is equal to 16 pi, which is equal to 50.27. So it's 50.27 centimeters squared. But of course we don't want the full amount because we only want this this blue zone in here. And that blue zone is 3/4 of the full amount. So area of sector equals 3/4 of means multiply. So it's 50.27, which is equal to 37.699. So that is the area of the sector that we are talking about here. It should be 37.699, and correct to one decimal place is 37.7 centimeters squared. So that was question 3, part 3. I already did a question part 4 for you, so you should be okay for 4. It's the same method. And then we're going to now take a look at question 7, okay? Calculate the area colored blue. So we have a circle. We have another circle inside that circle. So the word that describes these two circles is concentric. Okay, it's a really nice word, concentric circles. A circle within another circle, and the centers of each circle have to line up. Okay, that's what's known as concentric. And if we had a circle like this, they would be eccentric. So concentric means everything lines up, the centers are in the same place. Eccentric means the center of this circle is not in the same place as the center of that circle. They would be eccentric. And that's why we call people eccentric, because they're a little bit kind of off. I don't know what I'm doing there, sorry guys. So that's, yeah, nice phrase there, eccentric and concentric. But luckily enough, we have concentric circles here. It won't actually affect us, even if they were eccentric, but it's nice to have concentric circles. We're asked to find this blue area, and we are told the two different radii. This one here is 6, and the near one is what, 3.5? Okay, so I'm going to work out small area first. So that's going to be the white space in the middle. The small area is equal to pi by 3.5 squared, which is equal to 3.5 squared multiplied by pi gives me 38.48. And then I'm going to work out the big area. And what I'm considering to be the big area is not the blue area yet, but in fact, if this was the area of that great big disc there, okay? So the area of that red disc, okay? So it's going to be area of big disc is equal to, so it's pi by 6 squared, which is equal to pi multiplied by 6 squared equals 113.097. So just like we were dealing with the rectangles, one rectangle inside another rectangle, we can find out the blue area. Blue area equals 113.097 minus 38.48. So that is equal to 74.6, let's say 2 centimeters squared. So the area of that blue ring is 74.62 centimeters squared. So we were using that same skill we had last week with the rectangles, whereby we can take away small areas from big areas to get the area we need. Yeah, so it's the same, exactly, works exactly the same for circles. So I'm going to leave it there, and I will check in with you guys again tomorrow on Wednesday.